Hi class. I'm going to take a few minutes here and go over your PhET wave on a string lab. The first part of your lab was to make different amplitude waves and to see if the wave speed was affected. So I'm going to go ahead and make a very low amplitude wave, and you can see it going across to the right and it's going to bounce back to the left. Then I'm going to go ahead and make a very tall wave right now, and we can look to see how the speed of the wave is affected. And if we continue to watch this, you'll see that the taller amplitude wave never catches the low amplitude wave. And if we continue to look, we'll see that the speed of both waves is the exact same. So it turns out the amplitude of a wave does not affect the speed of the wave. The next thing you guys did was test the tension. In real life, this could be a different spring, it could be a different slinky, a different material. It could be a slinky that may be stretched out or shortened. So in any way that you affect the actual material of the slinky is kind of affecting the tension in this experiment. So I'm going to go ahead and make a wave that has a high tension, and you can see it going across and coming back, so maybe it takes a couple seconds to go each way. And then I'm going to stop and restart it, and I'm going to put low tension. And you can see that the wave is much, much slower. So it's really easy, simple. Everyone got that one right. You can see that the tension or the length of the slinky or the material of the slinky is going to have a very huge impact on the speed of a wave. The last thing you guys had to do was change the frequency of a wave. So I'm going to go ahead and start making some waves here. And I'm going to put no end. And what I want you guys to be able to see is that if I do a low frequency like this, or if I do a high frequency, those waves still are the exact same speed. So again, if I go super low frequency and you follow a crest, or if I make a super high frequency and follow those crests, the waves go at the same exact speed. So frequency does not have an effect on the speed of the wave. It's only the material or the tension. So to summarize this, you may want to put this into your notes because you're going to have a few questions on this on your last test here of remote learning. So you should know that amplitude does not affect the speed of a wave. And there's some good examples of this. If you have a loud sound or a bright color, that affects what we would describe as the amplitude of that sound wave or that light wave, and that's not going to affect the speed of the wave. Now, number two, if you change the material, if you change the tension, it's going to have a major effect on the speed of a wave. Light and sound will travel at different speeds in different materials, which is why sometimes light looks bent or broken, pencils and water look broken. Sounds seem to sound differently in different materials, like if you're underwater. And the last thing is frequency does not affect the speed of a wave. So the different colors we see are because of the different frequencies of the light, or the sounds we hear are different because of the frequencies of the sounds. But the speed of light, the speed of color, or the speed of someone's speaking voice, whether they're a boy or a girl, or high pitch or low pitch, is not affected at all. So the speed of a wave stays the same for a light wave or a sound. It's not affected by the frequency. That is about it. You can go ahead and pause this and put this into your notes. Thanks. Bye.